Hello, 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 everybody, and welcome back. We're going to look at our second written question, question number 29. So hopefully you've given this a try, and if not, pause the video and try the question for yourself. Question 29 says, use the intermediate value theorem to show that the equation 4 to the x equals 5 minus 3x has a solution in the interval 0 to 1. Now they specifically say intermediate value theorem, so we should be prepared to sort of invoke that at some point as we solve this. What does the intermediate value theorem, or IVT, say? Well, it talks about a function f of x that is continuous on a closed interval a to b, and it says that if you have a value d that is between f at a and f at b, lies strictly between, I believe was the language we used in class, then there is a d in the open interval, so f of d equals the capital D value. Okay, so we've briefly reminded ourselves what the intermediate value theorem is, and heck, if we just wrote down what we remember the intermediate value theorem as, we might even get a mark depending on the marking scheme for this paper. Alright, so remembering the intermediate value theorem here is key, and as soon as I do that, I notice, oh, well they're also talking about an open interval, so I might start thinking that a is 0 and b is 1. Okay. Well, what else do I need? I need a function that's continuous. I've got two functions here that are continuous. Could we in some way use them? Well, we can, but we only need one function for the intermediate value theorem to work. So, why don't we turn these two functions into the same function, well, a single function, by bringing them all over onto the same side. Okay? Intermediate value theorem doesn't work well when there are two functions, and you might say, well, which function should I use? The answer is you don't. So the first thing we're going to do is we are going to add 3x to both sides and subtract 5. So we need to show that this equation here is satisfied. That's what we'd like to show. That 4 to the x plus 3x minus 5 is equal to 0 for some value of x in 0 to 1. Okay. But now I have just one expression. So I might say something like, let f of x equal 4 to the x plus 3x minus 5. Now this is an exponential plus a polynomial. F is continuous. And I don't really need to justify that anymore. I mean, you could say, yes, there's an exponential and a polynomial, and that would be fine. But it's fairly clear to anyone who's looking at this, anyone who knows what the intermediate value theorem is, that this function here is continuous. Okay, so I've got f. It's continuous, not just continuous at a particular interval, but it's continuous everywhere. But more specifically for the intermediate value theorem, I might highlight that f is continuous on 0 and 1. Okay. Now, in order for this equation here to be satisfied, I need to show that at some point f takes on the value 0. Well, that's exactly what the intermediate value theorem is telling me. Okay, so the value capital D that we want our function to equal is going to be 0. So for the intermediate value theorem to work, I just need to show that f at 0 is above or below D, and f at 1 is the other way. That this capital D, this 0 value, lies between 0 and 1. And you may remember we did exactly one of those in class. All I need to do is show that f of 0 is positive or negative, and that f at 1 is negative or positive. Okay? As long as one's above 0 and the other's below 0, 0 is strictly between. And that's where the intermediate value theorem can strike. So, let's just do some computation. F at 0 is 4 to the 0 plus 3 times 0 minus 5. That's 1 plus 0 minus 5. That's negative 4. Okay. F at 1 is 4 to the 1 plus 3 times 1 minus 5. That's 4 plus 3 minus 5. That's 2. Look at that. We've got a negative value and a positive value. So, since 0 lies strictly between f at 0 and f at 1, the intermediate value theorem, and I'd probably abbreviate it IVT, tells us there is at least one, and since they wanted a solution, we might say x, there's at least one x in 0, 1, so that f of x equals 0. But if f of x is equal to 0, then that tells me 4x plus 3x minus 5 is equal to 0. And that tells me 4 to the x and 5 minus 3x, which is exactly what they wanted us to show. So we're all done. But we've explained what we're doing at each stage. We've got a function. We have noted that it is continuous. We have the target value, d, being equal to 0. I've shown that f0 and f at 1 are negative and positive. I actually did my computation, so that when I say 0 lies strictly between, I've justified that. And now the intermediate value theorem tells me there is an x in 0, 1, the open interval that they're asking for, so that f of x is 0, and I just get it back to the equation they want. Okay? So that was question 29. Up next, question 30. I'll see you guys there.